The LPC1700 series is based on the ARM Cortex-M3 core Revision 2. This core offers several enhancements over the ARM7 core, including advanced math features like single-cycle multiply and hardware divide. The core also gives an option to add a new memory protection unit, which allows users to protect up to 8 distinct memory regions from accidental overwrites. The Cortex-M3 core also adds a nested vectored interrupt controller that provides for fast, deterministic interrupts with up to 32 priority levels. Finally, NXP has chosen to add the optional core block called the Wake-Up Interrupt Controller that allows for quick, elegant exits from sleep states due to any user-chosen priority interrupt. The key differentiator of the LPC1700 series is its best-in-class performance. The LPC1700 series executes benchmark code on average 35% faster than competitor Cortex-M3 parts at the same clock speed. But the LPC1700 series is not limited to the 40 to 80 MHz maximum clock speed of the competition. The LPC1700 can operate at 100 to 120 MHz maximum clock speed. This means that the LPC1700 series can execute the emBC benchmarking code more than twice as fast, giving customers higher performance and/or lower power consumption. But performance is not the only differentiating feature of the LPC1700 series. The LPC1700 series has a wide range of advanced peripherals that are able to operate simultaneously without bottlenecks. There is an Ethernet controller with a dedicated Direct Memory Access (DMA) controller, a full-speed USB 2.0 interface that supports host, device, and on-the-go operation without the need for an external PHY, and 2 CAN.20B controllers with global acceptance filters that minimize CPU overhead. It also has 3 I2C buses that support the new Fast Mode Plus data rates and 4 UARTs. The LPC1700 series also has 3 SPI peripherals, an I2S interface for digital audio I/O, and 4 32-bit general-purpose timers with capture and compare. There is a standard PWM block as well as a motor control PWM block, and a quadrature encoder interface for supporting 3-phase motors simply and efficiently. In addition to the huge number of digital peripherals, the LPC1700 series also has some advanced analog peripherals. It has a true 12-bit analog-to-digital converter with 8 channels. There is a 10-bit digital-to-analog converter with a dedicated timer that can generate its own DMA request. Finally, there is an extremely low-power real-time clock, complete with calendar conversion that does not require the CPU to power on. This allows the part to operate in deep sleep modes with the real-time clock consuming well below 1 microamp. Having the highest performance and the best selection of peripherals is only part of the value proposition of the LPC1700. The NXP LPC1700 series offers the best debugging and emulation available on any Cortex-M3 microcontroller. It offers the new 2-pin serial wire debugging that was developed for the Cortex-M3 core, as well as the traditional 5-pin JTAG connection that is part of the other ARM cores. NXP also offers the embedded trace macrocell interface that simplifies the debugging process by offering real-time tracing capability with 8 breakpoints and 4 watch points. By offering the best debugging capabilities, NXP allows customers to produce working applications more quickly and easily. One of the reasons so many customers are moving away from proprietary cores to ARM cores is the broad tools and software support available for ARM processors. The LPC1700 series is backed by an ever-growing number of evaluation boards, integrated development environments, debuggers, emulators, compilers, software stacks, and many more. In addition to the traditional partner-supported tools from High-Tech, IAR, Kyle, and Code Red, the LPC1700 series is also supported by mbed and LPC Expresso. The mbed tool gives customers a rapid prototyping platform to test out ideas and concepts in the quickest way possible. The LPC Expresso platform offers the lowest cost way to evaluate, explore, and develop with the LPC1700 series with NXP tools. Beyond hardware, the LPC1700 is also supported by an increasingly large amount of software tools. NXP provides sample code bundles for a variety of compilers, along with the standard SimSys code bundle that is available for all Cortex-M3 devices. There are also license and royalty-free libraries for digital signal processing, DSP, and Class B test libraries. The DSP library allows customers to perform DSP functions without having to buy a dedicated DSP processor. The Class B test library lets customers use certified code to help pass qualification of safety-critical devices, such as white goods. Finally, the LPC1700 series is supported by more than 20 application notes and a handbook library to help customers from the start to the completion of their designs. All of these items are available at www.nxp.com/microcontrollers. Finally, NXP is expanding its LPC1700 series beyond the LPC1760 and the LPC1750 series. The LPC1770 and 80 series add new peripherals and functionality while maintaining the lead in performance over the competition. These new series are pin-compatible with the popular LPC2400 ARM7 series from NXP. The LPC1770 and 80 series start with the LPC1760 and add additional RAM, an external memory controller, an SD card interface, 4 kilobytes of EEPROM, and larger packages. The LPC1780 series is also the first Cortex-M3 microcontroller with an LCD panel controller.